Yes. Now we need to be able to make reasonable estimates of physical quantities. For now, I shall limit myself to physical quantities such as length, the one that we're familiar with, time, and maybe mass. Now, what do you mean by reasonable estimates? Well, let's start looking at the length, and that's we're familiar with. Let's say we have a person, okay, person standing on the ground. Now, how tall do you think this person would be? Of course, we all vary in height. We all have different heights. But when we say estimate, it's okay if we are out by maybe 10 or even 50 centimeters, as long as we have very roughly, maybe plus or minus 50%. It doesn't really matter. That's what we mean by an estimate. Of course, the more accurate, the better. Now, so from we can start with ourselves. Your height might be, say, 1 point something meters, and it's usually between 1 and 2 meters. So I would say typical adults would have a height of, say, 1.5 meters. A child maybe between 0.5 meters to 1.5 meters. So that's the kind of height that we're talking about. So if it's 1.5 meter could be a reasonable estimate. Now, what's the next length that we are familiar with? Well, maybe the room. What kind of lengths do we have in the room? Okay, well, we have, say, the ceiling. Right, that's the ceiling of the room. How tall do you think the ceiling is? Well, think about whether you can jump up and touch the ceiling. Well, usually you can't unless you have a really low ceiling. So it might be higher than yourself by maybe another meter or two, depending on how big your room is. So I would say the height of the room, if you could roughly say that it's about, the height above you is about as much as your own height. So it might be about 2 or 3 meters. Okay. How about the size of the room? It might be that kind of distance as well, maybe 3 or 4 meters wide and long. Now, but what's the use of making these estimates? It gives us a good idea of how big things are, and it's usually useful when we try to get an idea of say the kind of size of a room that we want, or how much do we have to pay for this house, for example, if we have a rough idea about the size of the area. And we also know, for example, if let's say let's go to volume, for example. If you have an idea of say the volume of a bottle of water, right, that will help us to estimate maybe its weight, for example. Now let's start with say estimating of volume. Let's go on to that. We are familiar with probably things like drinks and milk that we would buy in the market. So if you think about milk, let's say 1 liter of milk, L-I-T-R-E, or 1 liter of fizzy canned drink, Coca-Cola, whatever. So 1 liter would be is usually in a box or a bottle. Okay, perhaps 2 or 3 times the size of our own hand. Is that kind of size. Now that would be about 1 liter, right? Or some big bottle of sugary drinks. Now, so 1 liter, but how big is this box? What do you mean by 1 liter? 1 liter is really the same as 1,000 cm cubed, 1,000 centimeter cubed, right? 0 there. And if we think about it in terms of the length of the box, that will give us an idea what the volume is just by looking at it. So 1000, if you think about finding the volume as multiplying the length, breadth, and the height, we might imagine splitting them up just very round, just for fun, into 10 times 10 times 10 cm cubed. So if you have a cube with 10, which is 10 centimeters long, 10 centimeters wide, and 10 centimeters tall, that would actually have a volume of 1 liter. Now we roughly know how much is 10 centimeters. You can just look at your ruler. It's maybe about the size of your hand, depending on how big your hand is. So it's that kind of distance. So if you have that idea, then next time you see a cube, all right, with a side that is up close to the side of your hand, then you can tell that the volume is about 1 liter. And this kind of knowledge could be useful if you need some idea of what volume you want to put things in or to carry water in. Now, I once have an exam question at university actually, which asked me this very interesting question about estimating time. Let me write that down. The question is, Big Ben. You might have heard of Big Ben. Big Ben is a clock in London. And I've never heard Big Ben, but apparently it chimes. There is a bell there that chimes at certain times of the day. And the exam question I had was, essentially, it was asking how long is this? Does the sound of the bell in Big Ben last for when it was hit? You can think of it this way. So imagine that there's a bell in Big Ben and someone or some machine hits it, and then it vibrates on its own and produces a sound, and after some time the vibration dies down. So the question is essentially how long is this chime? Now, I was really stuck. I had no idea what it was because I've never been I've been to Big Ben, but I've never heard the sound. Now that I think back at it, I could have easily made a reasonable estimates based on maybe other bells that I've heard at churches or even seen on videos, because it's not going to be that much different, and we just need an estimate. As long as it's not 1,000 times different, or maybe even 100 times, it's probably okay. So if you think about what we know about a bell chiming, you might hit the bell and the bell goes dong. But if it's a really big bell, the sound might last for a longer time. But how long can it last? Think about an unlikely time. Can it last for as long as an hour? Most definitely not. Can it last for as long as 10 minutes just by hitting a bell or ringing on its own? That's unlikely as well. Maybe 1 minute. Maybe a really huge bell. You can imagine it goes dong, and you start counting for 60 seconds and it's still going on. It's probably a really huge bell. So I would say a number of seconds. If you start counting 1, 2, 3, seconds, it'll probably die down after a number of seconds, and very unlikely to go up to 1 meter. So if I were to see this question again today, I would say that the time of the Big Ben bell would last for about 10 seconds or less. Right? So that's one way we can start thinking about estimating time. Now let me think of another quantity. Like let's say walking. All right, let's think about walking speed. If you have a person walking, try estimating the speed. All right, this person Right, he's walking in this direction. What do you think typical speed is? Alright, like I say, an answer that's a few times is within a few times will be acceptable. We're not going to say that he's traveling at the speed of light. So how would we go about estimating his speed? Well, okay, we know that speed v is let's say a distance over time. Let's try and think about within say a certain time, what is a reasonable distance you can walk, or that you can walk, for example. So we know how to roughly how long a second lasts for. If you think about the clock that goes tick tock tick tock, so that a tick tock will be a 1 second. So can you walk a step in a second, or you can actually walk a step in half a second? Because if you go tick tock, you can just imagine yourself walking 2 steps, right? A tick and a tock. So if you go 2 steps every second, how much distance do you go in 1 step? That really varies with people. It can some people have shorter steps, some people have longer steps. How about a meter? Maybe if you stretch your leg a bit, depending on how tall you are, you might manage 1 meter or maybe a bit less in 1 step. So let's say in 1 second. Alright, these are the things that can go through our mind. So let's say in 1 second he goes 2 steps. So let's say 2 steps is about 2 meters. So this gives us our answer, our estimate. Right, it will be 2 over 1, which is 2 meters per second. So that could be a really quick estimate of our walking speed. Now, why would we want to estimate our walking speed? Well, for example, if you might want to know roughly how long it takes you to walk to the market to get a pint of a liter of milk and come back in time for lunch, right? So that your friends don't wait for you for too long. So you can use this to give a rough estimate and tell them that it might take you 5 minutes or 10 minutes. Okay.